Okay, so we have a problem here that we solved by hand, and we got the solution x equals 5. That was the what I call the obvious solution. I also went through the graphing of it, and the graphing of it, we determined that there was two other points of intersection that were kind of difficult to come up with, but approximately, kind of looking at over here about 0.7, and over here, I'm going to say about 1.7. All right. Now, what I want to do is talk about how to find those solutions. The guy that did the video, by the way, he used the Lambert W function. I'm using Newton's method. All right. I'm going to think Newton's method is a general method for finding roots, and it's really kind of quite effective at doing so. So what I want to do is go to Sage and type this in. All right. So I'm going to type in reset. And we've done this many, many times in this particular worksheet. And then the function f of x. And I want to tell you what f of x is. I'm going to copy paste it though. And then we'll talk about what that is. And what that is this equation here, x to the 10th equals 25 to the x solved for 0. And Newton's method is about finding roots, and roots are 0. So that's what I'm looking for. Right? The next thing I do is I talk about a new function called Newton's method. And Newton's method is equal to x minus the function divided by the derivative of the function, diff f of x with respect to x. All right? Okay. Then what do? I take an initial guess. And the initial guess I'm going to take is, I'm looking at over here, I'm going to take this guess over here. Now I'm going to say x is around minus 0.8. And then what I do is I keep repeating this until there's no change. Now, if I use Newton's method and it tells me the answer is minus 0.8, there's no change. Right? I think there's going to be a change though. So what I'm going to do is I'm going to say x equals, now x equals Newton's method, and it's going to be Newton's method evaluated x. And what's x? X is minus 0.8. I want to display the x, and I want to see if there's any change. All right. Now, when I display the x, I want to make sure it's an approximate answer. So I'm going to use the n notation. And I made a mistake. All right. Now, I wonder what that mistake is. And I'm going to look back over this. And I'm going to clear the screen. And I'm going to use my up arrow. And let's see what I did over there. Let me see that f of x is defined. X to the 10 minus 25 to the x. Reset. I did that. I'm just looking back over my code, by the way. Let me see if I did Newton's method correct. Oh, you know what? I see it now. Newton's method is a function of x. This can happen when you code, by the way. You're going to make a mistake, and you think you typed it in right. You say, what went wrong? I know I made a mistake, by the way. The machine didn't make a mistake. I made the mistake. Let's go back to that initial guess, by the way. And let's go back to my Newton's method again. All right, I'm just going back over the code, and I'll type this in now. And what does this display? So it's definitely been a change. Not a big change, but a change. Minus 0.8, now it's minus 0.78. I can hit the up arrow and do it again. There's definitely been a change. All right, I can see that in the first two digits. Keep going. Getting closer, isn't it? But still a change. His numbers look different. Numbers look different. Numbers look identical now. Digit by digit, by the way. So within the precision of the machine, it's doing okay. All right, it's saying that's what the answer is. I just want to briefly go through that. I'm believing that this x now raised to the 10th power would give me a number. Let me hit that return. Let's see what happens, by the way. Wow, that's crazy looking, isn't it? I want to point out what happened over there. It's using numbers that it's not approximating. I want to approximate that number. This is why I use that .n notation a lot. It's computing odd numbers. Gets this number over here. And now I want to do 25 to the x power. And what I'm going to say, I want x to be, you know what, I'll just do x, and then I'll do .n notation again. All right. You see how those numbers are matching, right? I'm just evaluating it. Within the precision of the machine, they match. Let me do the next one. And the next one, it's really the same exact code, by the way. But I want to use a different guess now. I want to use x equals 1.8. All right. I'm going to pull up Newton's method again. What happened? There's a change. I'm going to pull it up again by using the up arrow. Definitely been a change. I'm looking at those numbers, are not the same number. And again, within the precision of the machine, they're not the same numbers. So let's take a look at that. It's still changed, by the way. Still changed. Wow, I don't think it changed there. So if I keep doing this, it's not going to change, by the way. Now here's the deal. I want to still evaluate it. And what I'm going to do, I'm going to do x. Now x is that number to the 10th power, but I want to approximate it. Whoops, that didn't do so well, did it? Let's try again. You may wonder what happened. I want to go back over the code and tell you what happened over there. It's actually approximately number 10. Let me go back over here. I know it seems strange to you, but really what I'm doing is I want to approximate not 10, but I want to approximate x to the 10. Let me do that now. Gee, I get that number. Now let me do 25 to the x. And I'm going to approximate the x now. Are we getting the same number? Well, within the precision of the machine, we're getting the same number. And that's good news. That's about it. Thanks for paying attention.